Right, from speaking to dogs, we are now going to talk flying taxis and such like with a very high-powered panel who are finding their way to the stage. I'm going to let them introduce themselves. Obviously, I don't need to go on about the breathless headlines that have been around for the last 3 or 4 years on all forms of both package delivery and human delivery, increasingly flying cars, you name it. Well, these are the guys at the chalk face in different ways. Eric, why don't you kick us off with a brief introduction to what you do, where you're at, and who you're supplying.
Excellent, thank you. So I'm Eric Bartsch, I'm Chief Operating Officer of VerdeGo Aero, and we are one of the companies behind the scenes supplying this flying car industry with technologies to make their aircraft viable for commercial missions. We really started out of some electric and hybrid electric aircraft programs that all 3 founders have worked on for quite a number of years. Actually logged some flight time myself as a pilot of electric aircraft back in 2013 and took one through European certification. And really realized at that time that electric power was really a revolution, but that what we were doing with it early on in this industry was not perhaps the best application. And what we really needed to do was move out of force-fitting a new propulsion technology into old airplanes and instead design new airplanes with a clean sheet of paper. And really that's what you're seeing with this flying car industry. And so VerdeGo Aero is focused on the powertrains that go inside these aircraft with a parallel path of both hybrid electric as well as full battery electric powertrains to enable these aircraft to address the commercial missions that are really going to make them viable in large numbers and ultimately that are going to allow all of us to move around cities much faster and be where we want to be when we want to be there.
Right, and so a lot of this is about regulation and a lot of this is about how you travel around cities and all of the extra technical challenges that presents. It's there's a leading edge, but there's a bleeding edge, isn't there? Jesse, you're going to explain to us a little bit about, this is a crowded market, right, of a lot of small companies and some big ones trying to conquer a lot of very complicated tech.
Yeah, that's right. I would say Skylift was definitely on that bleeding edge. We were doing a lot of experiments and getting a lot of landmark regulations and hitting those milestones for technology that just didn't exist. So Skylift was focused on last mile logistics, and particularly we were working with public agencies to try and figure out how we could deliver food, fuel, and water, bullets to the military for their operations, for their forward operations, and also public agencies like the fire department to help them be able to do resupply to the firemen to fight wildfires faster. Now, unfortunately, Skylift is defunct, but it's continuing as a research project over at Caltech, where one of my co-founders is the director of drone development. And I myself am going to be teaching a course on drones and robotics at UCI starting in 2019.
Okay, Stephen, now we actually have a visual aid, which we're going to call upon in a second, just to give us a picture of what you're working on right now, but just give us a picture of what that is.
So Zeva stands for Zero Emissions Electric Vertical Aircraft, and we are working on a 1-person electric aircraft.
With a pilot?
With a pilot, well, the pilot can be the passenger, but it's 1 person. Or it can be autonomously flown or remotely flown as well.
A second, okay. But basically we're talking about 8 blades, right?
Yeah, so what you're seeing here is the back of the aircraft, and there's 4 on the back and 4 on the front. This is the actual hatch where you get in, the entire back will lift off. You stand in a prone position, and then if you go to the next slide, I think, or maybe a few slides forward, the whole machine transitions. So what's unique about our configuration is that there is no complicated tilt rotor mechanism. So it's solely the entire machine does the transition. Very lightweight. The whole entire machine with a pilot is about 600 pounds.
And you have a target for next October for getting that?
Yeah, so our impetus for existing is that we put a team together to go after the Boeing-sponsored Go Fly prize. It's $1 million X prize. The culmination of the effort ends in a fly-off in October of next year, so we have a lot of work to do. Yeah.
Okay, we haven't got the picture just yet. Maybe we'll get it in a second. But I mean, essentially, I don't want to get kind of too deep into the weeds on the technical challenges here, but we do need to touch on them, right? We're talking. You've all been talking about let's say, supplying the military in a battlefield situation, or I don't know, supplying medical aid. We have the story, don't we, about in Africa delivering blood supplies to remote clinics and so on. But that is one environment. The urban environment is where the money is, and the urban environment has a very particular set of practical challenges. We're going to get onto regulation in a second. Just to describe the practical challenges, if you don't mind.
So the practical challenges, there are a few of them, but the number one performance metric for all of these vehicles in an urban environment is noise. That's the Achilles heel to the helicopter, because there's a valid question that people ask all the time, which is, okay, we've had helicopters for a long time, why aren't we just using helicopters for this? And there are some economic reasons, there are some safety and redundancy reasons, but really the primary reason that the helicopter doesn't work for urban transportation is noise, and the public has just decided that this is not an acceptable solution. And so one of the opportunities that we have with electric propulsion is to create an aircraft that is dramatically quieter, also with a lot more redundancy, with more rotors on it so that it's more fault tolerant, and really create a better option for commercial transportation inside cities. But that noise is the number one challenge. And then we of course have the challenge of how do you fit these in with air traffic? And that's really a longer term issue, because in the early years of operation with urban air mobility, we're not really going to have dramatically more traffic than we have now. And so people ask, well, is air traffic control environment going to be able to cope with this? And I think the answer to that is really yes for the early phases of the scale up of this market. And then there will inevitably come a time when there has to be a transition, and the drone industry is already working with new ways of basically accessing and utilizing the low altitude airspace, such that it can be shared across a wide variety of users.
And in the short term, we're talking not so much about, we shouldn't be picturing taxis so much as perhaps buses, right? I mean, these are going to be delivering,
Right.
That's the most likely short-term economically deliverable product.
I would say yes. There is a divide in this industry, and I'll put where Stephen is aiming is at a little bit different spot, but there are a lot of people that are targeting 2-seat autonomous vehicles or 5 to 7 seat vehicles that have a pilot on board and then quite a few passengers. And so one of those approaches obviously hinges on autonomy being approved. The other approach is really more of a helicopter replacement that's quieter, more economical, and and safer. And I think we're seeing valid reasons for both classes of aircraft existing. And certainly VerdeGo, our approach is to support both markets and to deliver modular powertrains that fit both types of aircraft. So we're agnostic to that.
Jesse, right now, what are the technical limitations that are stopping this being a product that we could see right now? What's getting in the way technically?
Yeah, so right now, everybody is really familiar with software-defined hardware. And that's what made drones so successful, so successful in the first place. And so we want to do that for our transport vehicles. What's in the way is the actual hardware capability. You can't just scale a drone up. Your mass density increases faster than your power density. Pretty soon you can't lift your own batteries. You can't fly a helicopter. You can't electrify a helicopter, because a helicopter is fundamentally a different type of vehicle. It's not optimized around electric. And this is why you see all of these new prototypes of these mixed wing aircraft. They used to be far too complex for any individual pilot to fly. But now the convergence of all of these technologies allows for new flight characteristics, new systems that with this software-defined platform may be able to surpass the efficiency of a helicopter and address a lot of these legacy problems.
Stephen.
By far and away, the biggest challenge is still what Dennis Bushnell talked about, which is energy. I mean, getting your hands on lithium metal batteries for a startup company is super challenging right now. And we really have to have that energy density to make this thing work well. That's the biggest challenge that we face. But
So the batteries are by a factor of what? Just too weak to deliver what you need them to do?
Really just 1.5 to 2 times is what we need. I mean, we can fly with Tesla-style batteries, but our duration isn't enough for the contest.
What kind of duration do you need to
We
be
need to
economically?
stay in the air for 20 minutes with a 10-minute reserve. So 30-minute total time.
How far will that get you?
Depends how fast you're going.
Well, exactly. How fast can you go?
We about 120 miles an hour, so we're giving it about a 35-mile range, which is right in the sweet spot of commuting in the urban environment. So.
We've touched on regulation here. Now, we talked about this, obviously, in Europe and the US, in any built-up environment, that's not going to be possible right now, okay?
Right.
Yeah? But perhaps Asia, the Middle East, people, the regulators, they're a bit more cowboy about this.
Well, I think that they're probably more progressive, and
Okay.
they have a vision for this technology that just gives the FAA a headache, you know.
So is that where you're going to start? Do you think? I mean, you imagine when it becomes commercially
Well,
viable?
I think there'll be a lot of people in the States that have an affinity to it, that don't have to fly in an urban environment initially. They're going to be the early adopters and the thrill seekers and the people that want to use their air vehicle for helicopter
Flying around the
skiing.
ranch.
Yeah. So, absolutely.
Are you seeing, I mean, this is a global market, right?
Right.
And we've got the people like Uber and the big players in this, and then there's about, 100?
There are more than 100. I've actually lost count of how many aircraft programs there are in this industry. It's a crowded space, and there are some great approaches to this. There are some not so great approaches to this. I think that the thing that people should take away is there's a lot of really good innovation going into this market, and there will be a narrowing of this field inevitably over the next 5 or 6 years as we head into the marketplace. And it is very much a global market. I mean, if you think about the most crowded megacity urban environments around the world, the majority of them aren't in the United States, and in fact, the majority of them aren't even in Europe. You're talking about places like Delhi, Bangkok, Tokyo, Shanghai, Sao Paulo, Jakarta, Mexico City, where there are a lot of people who need to move places quickly, and at the same time, the infrastructure has lagged in many of those places even more than it has lagged here in the US, and therefore there's the real potential to give people their time back, to do in 8 minutes what you would otherwise take 2 hours to do. And that opens up a lot of opportunities, whether it's for business, for pleasure travel, or EMS emergency services. There are a lot of needs for wanting to move quickly in an urban environment, and we don't have enough opportunities to do that right now.
Is there a lot of competition from China and India? I mean, are there people doing the same work there?
There's a fair amount of competition in China. There's not nearly as much in India, although we're seeing some strong interest in India as a region to operate these vehicles. I'm not seeing a lot of energy there in innovating and developing the vehicles, but it's certainly a huge market, and there are a lot of people there who are saying, we need to bring this in. And as for an example, the EMS helicopter service for emergency medical reasons is extremely underdeveloped in India, and there's an interest there in skipping past the helicopter to the next generation of vehicle as a way of bringing that to more people.
Jesse, you were about to butt in.
Oh yeah, I'd love to jump in there because I think you really hit the nail on the head. There's a key difference. Point A to point B for transportation has been solved. It's a matter of economies of scale. And you can put a bunch of stuff on the back of a truck, and we'll never be able to compete with that with a flying vehicle. But it's when you have something that you need on demand, that all of a sudden you need to get it there quickly and affordably, and that's where we have to drive the cost down. It's that last mile of delivery that is the real problem. And when you're flying, when you have a terrain agnostic vehicle, you're flying an aerial route, you're 42% shorter in an urban environment. And that's why this is the right solution. And then playing into the larger scale of, we've also talked a lot about the environment at this conference, distributed energy storage. There's a lot of long-term reasons why this is a great solution and it needs to happen. The question is more, what are those key technologies that are going to bring all this together and crack that equation so that we have superior performance to a helicopter and can actually make this work?
Briefly, I mean, we're talking mostly, aren't we, about delivering people to places. What about parcels and things like that? I mean, a few years ago, Amazon was about to start delivering stuff to all of our doors, our parcels, using drones, which always struck me as terrifying. It never actually happened, not surprisingly, for regulatory reasons, I guess, and suddenly it's just been totally forgotten about. is FedEx not thinking about doing this from the airport to at least to the central depot or something? And how close are we to that? Why that would be presumably be much, much easier.
Yeah, Swiss Post, DHL, I mean, all the big boys, everybody's thinking about this. They all have put money into startups that haven't really gone anywhere. I think the key here is you have to actually solve a problem. And when you have things that are low value and very predictable like mail, it doesn't make sense to go to all of this trouble. With Amazon, there is a way to make the business model work, but it's not what they think. And we've told Amazon this. We've talked to them a few times. Basically, you want autonomous drones in a warehouse where you take it vertical and reduce your cost per square foot. You do the urban farming model where you move that warehouse close to the customer, and that's how you take the cost out of last mile delivery, as opposed to what they're doing now where they're driving these long distances and they can't get the economies of scale on a truck to do same day delivery with your warehouse outside the city.
Okay. Sorry, yes, Stephen.
Yeah, we have a little bit different view. I think one of the applications for our vehicle is going to be people that live in cities, like most of the cities that you mentioned are water-bound, right? So I think that having this capability of point A to point B over land or water changes the real estate market tremendously. And so people that live on islands, I think Mark might be our first customer, I'm not sure, but being able to have an autonomous vehicle that gets you through the air anywhere within a radius is a powerful thing. And we're looking out further than that too, because we see Uber, or who comes after Uber, dominating the rooftops in the cities. If you have your own vehicle, and if you have your own vehicle, how are you going to, you can't get access to the building that you want to go to. So we actually have a technology that we're working on that allows us to dock to the side of a building. So for example, you can, if you live on the 40th floor of your building, you could just walk out on your veranda and get in your machine and Batman off the side of your building and go to work. So that's the kind of vision that we have, in that we think that, what Uber's planning to do, their turnover rate is so high to make their system economical. They're talking about 1,000 moves per machine per day, and which is unfathomable how they're going to turn it around that stuff. So bottom line is the rooftops are going to be busy all the time. So how do you get real estate to land these things in the city?
Yeah.
That's the question.
Obviously questions, guys, so you can step up and ask those. Uber, you've mentioned them. I just want to quickly go through the regulation question before we get the questions coming in. Where are we at now? Uber, you described a little bit as a kind of battering ram right now, because obviously all these small players, no one listens to them. But Uber is spending its time in Washington, D.C. shouting at regulators to kind of...
Yeah, I was at, Eric and I were both at Uber Elevate this year. There's 1,000 people there from all over the world. And what they're doing a really good job of is evangelizing this idea and signing people up.
And what's the time frame, do we imagine?
The time frame is they're planning trials in 2025 in LA, Dallas, and Paris. And they're being very aggressive about it. Even if it slips by a year or two, that's still a pretty short timeline.
Ty.
Okay, just Ty Carlson, Pattern Computer. Just a couple of pieces of feedback and then a question related to it, because directly related to regulation, by the way.
Okay.
First, check in on Amazon, what Amazon's doing with Primare. Amazon in most cities have easy access within 50 miles. So I filed patents on Primare and for the drones. And Amazon is not giving up on the drones. It's just Amazon's classic, fly very low under the radar so you don't have to deal with a lot of the policy issues. Figure out what your plan is and then pop up so people can see you. But don't underestimate Amazon with regard to that delivery. To that extent, the regulations, particularly with the FAA, we're very concerned about dropping packages that are weighing 5 pounds. The FAA has regulations against anything flying under 500 feet over condensed air or over congested area, housing development, where people live. The restrictions regarding that, you looked at Tesla, for example, when Tesla's first car crashed, right? Oh my God, we can't have autonomous driving and all of this going on. So I think there's a real underestimation of the challenges both with the FAA, with the technology, with the noise, with the not in my backyard. Everything that has been with respect to drones think of it like 3 times the complexity, right, because of the weight and the noise and all of a sudden turning a neighborhood into an airport creates a problem. Tofino, for example, banned all drones. So I think we're going to see some challenges. So I think we need to think harder about regulation. I'd love to see how you think you're going to navigate that.
Very quick comment on regulation, and we can have another question.
So I'll just comment on regulations. I lived through the launch of the consumer drone industry and some of the commercial drone industry and how far out of line the FAA got with the realities of what was going on in the market. And I will say I've been pleasantly surprised at the group of folks that are working on this at the FAA at the Small Aircraft Directorate. And so GAMA, the General Aviation Manufacturers Association, many of us in the industry and the FAA are all engaged on the certification path for the aircraft, but also the operating concepts and how that's going to work. And at least for the aircraft that will be certified under Part 23, so basically that's anything with a wing, there is now a path forward. It's going to be a difficult path, and your point is absolutely spot on, that what we've done with the changes that have happened in the regulatory environment with the FAA, we've gone from this being impossible to this being extremely difficult, which is major progress, but I wouldn't downplay that it's going to be extremely difficult. And we're well engaged with the FAA and with the industry groups that are collaborating with them on how this is going to play out and what it's going to look like in the early years and then in the later years.
Sounds a bit like Brexit. Dennis.
Yeah. All right. The passenger business is urban. I know where you're going there, but urban is the last place I deploy these things. The urban canyons, winds, vortices, really, really hard to fly in that place. Very few places to operate from, even fewer emergency landing sites. Huge potential for damage, all kinds of people and property all over the bloody place. The acoustics associated with all of this stuff, the weather effects and amplification, and ATC is really difficult in these kind of areas.
Okay, well, you touched on the acoustic issues, but I mean, does anybody want to say anything about just the nature of the wind problems that you're going to find in a high-rise environment?
Ooh,
Stephen?
we haven't dealt with any of that.
Yeah, I mean, that definitely is something that would be a consideration. I think that air traffic control needs to be aware of those things on a real-time basis and route your traffic. But the other thing that we're kind of all glossing over here is that the thing that makes drones or quadcopters or whatever you want to call them possible is the micro technology, the MEMS and the microchips, and that stabilization that they offer is phenomenal, and it can respond to most of any of those issues that you talked about.
And I guess
This type of a business was tried in the 70s, as I'm sure you all well know. Mm-hmm. And there was a crash in a Pan Am building, as I remember. The thing rolled over. It was a helicopter, killed several people, and the whole thing stopped for 3 decades.
Yeah.
Absolutely. And that's something we all have to be very conscious of, is this industry is going to be under a microscope as it starts up, and safety is paramount. And I think one of the options we have with these new architectures for vehicles is the ability to make vehicles that are more fault tolerant than traditional helicopters have been, because these architectures, you have the ability now where you can have a failure of a rotor or a motor, and you can design redundancy in through electric propulsion architectures and distributed electric propulsion to where the aircraft can tolerate that and actually continue on to the intended destination and not have an emergency event. And so I take the point that safety is absolutely critical, and I think there are a lot of people in this industry that are very focused on leveraging these new technologies to actually make that possible.
Yes.
Can I jump
Sorry,
in
yeah,
here and
sorry.
just talk about that? So I want to let everybody know that there are viable business models that don't directly conflict with the FAA. We were working with public agencies. If a public agency has filed a letter of declaration with the FAA, they can deem an aircraft and a pilot airworthy. And so our vehicles were actually on the approved UAS list. You can buy one of our prototypes today and fly it with the Part 107 license, all legal. So there was no issue there. If you're creative about that catch-22, of being able to fly your vehicle, log the hours, demonstrate its reliability and safety, send that data for approval from the FAA. They give you those approvals, and we have demonstrated that.
But not over built-up areas.
So yeah, I mean, we avoid that. Again, the ecosystem around all of this is not something the companies up here are looking to solve. We're trying to find the best vehicle to solve the problem, not necessarily create that ecosystem with a regulatory environment.
Yeah, I was just wondering, under the optimistic scenario that all these challenges don't prevent you from realizing this vision, given how bad traffic is and the way things are laid out, I'm just curious what you think it will do for where people choose to live and the real estate patterns. Because I can imagine forces making people want to live more densely, but also making people want to live more spread out if moving back and forth becomes easier. So just curious what your opinions are.
Or on islands, perhaps. Stephen, anything to say about that?
Yeah, I think it allows people to live close, specifically I'm from Tacoma and Seattle, Puget Sound area, and there's great examples of islands that don't have ferry service, that don't get a lot of traffic. And it's going to cause the real estate in those areas to go up because people they're going to become very desirable places to live. They're close to the city, but they're not in the city.
I think just to build on that, though, you're going to have a balance between use cases because some of these vehicles are going to be used for daily commuting, in which case that is going to affect where people live. A lot of these vehicles commercially are going to be used for urgent cases, so it's the market that I see or the biggest market beyond some of the initial people who may be buying them who are very wealthy is the average business person who maybe 5 to 10 times a year has a really urgent need to move across a city. Maybe you have a sales meeting that's running long, you want to spend 2 more hours with your client and then hop one of these to the airport to make your flight out. You need to get across from one side of Shanghai to the other and try to conduct 2 meetings in one day. There are a lot of instances where there are hundreds of millions of potential consumers in the world who don't necessarily have a reason to, on a daily basis, jump into one of these vehicles, but 5 or 10 times a year, putting one of these on an expense report is going to be well justifiable and well worth the expense. And I think that's really the big market. It's how do you create a market where hundreds of millions of people occasionally over the course of a year have the ability to really get where they need to be when they want to be there.
Okay, a quick question, a quick date. I want a date prediction from each of you. When are we going to see functioning airborne taxi services of the kinds you're describing in, let's say, I don't know, London, New York, Paris?
Around 2025. Small scale, but yes.
Uber says 2023. I would say comfortably maybe 2030 is probably
2030.
more realistic.
Stephen?
2028.
2028. You heard it. We're going to be back in 10 years' time. We're going to be calling everybody on their predictions. Thank you very much. Thanks for your time.